Howdy AJP students. This lesson will cover the Pythagorean Theorem. This is a great tool to use when dealing with right triangles. The Pythagorean Theorem states, the area of a square on the hypotenuse is equal to the sum of the area of the squares on the legs. You may have seen the formula a squared plus b squared equals c squared. In this formula, a and b are two legs of a right triangle, while c is the hypotenuse. If you're unfamiliar with the term hypotenuse, it's simply the side of a right triangle opposite the 90-degree angle, and is always the longest side. This formula can be very useful when using a variety of problems. We all know that the SAT tries to trick you, and one classic way is to present a right triangle with a missing side that is not the hypotenuse. Be very careful when you set up the equation to make sure that you're doing it properly. In this example, the two legs would be this side here and this side, and the hypotenuse would be this long side that's opposite of the right angle. So to set this up, you would have x squared plus 3 squared equals 4 squared, and then you would solve that. When dealing with questions, you will often have an answer that is in radical form. For example, the root of 12. Do not try to simplify this answer. Use your calculator. You have it for a reason. You can easily compare decimal numbers with your calculator. Just work them out. Not a problem. You don't have to reduce these. Oftentimes, a problem will require you to use the Pythagorean theorem more than once. Again, make sure you set up the problem correctly. Make sure that your hypotenuse is the one that is the longest side across from the 90-degree angle. There are two special right triangles that you should be aware of. They are commonly referred to as the 30-60-90 and the 45-45-90 triangles. For the 45-45-90, or the isosceles right triangle, each leg has the same length of n, and the hypotenuse has a length of n root 2. Whereas the 30-60-90, or the scalene right triangle, the shortest side is the n length, the medium leg is n times root 3, and the hypotenuse is 2 times n. These quick thumb rules will help you easily solve these types of problems. Here's an example of each of these triangles. On the left, the isosceles right triangle, you can see the two legs there have a length of n, while the hypotenuse has a length of n root 2. And here on the right with the scalene triangle, we have our shortest side, which is across from the shortest angle, or the smallest angle, and then the middle side, which is across from the 60 degrees, is n root 3, and then the hypotenuse, the side opposite the right angle, is 2 times n. These are really good things to remember so that you can easily use them on the SAT. Now let's take a look at our first example. Example 1 states, determine the length of segment AB. And so if we look at this triangle, we have two right triangles, and we have a base of this larger triangle of AB. So to solve this problem, we'll need to find the length of this line segment using the Pythagorean theorem, and then the length of this segment using the Pythagorean theorem also. So again, you see we're using the Pythagorean theorem twice. So once we get those two values, we can add them, and then we'll have the length of AB. Let's go ahead and solve this problem. So what we'll do is set up our equation, a squared plus b squared equals c squared, and then we'll plug in the numbers. For the larger triangle, we have this leg of 3 squared, and we're missing this other leg, which is, we'll call it b squared. And we have the hypotenuse, 5, so we'll plug that in as 5 squared. On the smaller triangle, we have the same leg here, so 3 squared, and again we're looking for the other leg, so we'll b squared, we'll leave it as b squared. And we do have this hypotenuse, the side opposite the right angle, and that's 4, so 4 squared. So you can see here 3 squared plus b squared equals 5 squared, and the other smaller triangle, 3 squared plus b squared equals 4 squared. So we'll go ahead and do these squares. So we know 3 squared equals 9, and 5 squared equals 25. And over on the other side, 3 squared again is 9, and 4 squared is 16. So for the larger triangle, we'll rearrange and subtract 9 from 25, and we'll get 16. So the smaller triangle will take 9 from 16, and that's going to give us 7. So we'll go ahead and do that. So b squared equals 16 for the large one, and b squared equals 7 for the smaller triangle. Now let's check this out. So we'll say 16 and take the square root of that, and that's going to equal 4. So this long side here is actually 4, and then the smaller triangle will have 7. Take the square root of that, and that's going to be 2.65. So this distance here is 2.65. And what we'll actually do, we'll find that, and then we'll add those together. And we'll get 6.65, and you can see that. 4 plus 2.65 equals 6.65. And that's going to be our answer. We'll grid that in and move on to the next problem. Example 2 states, determine the length of segment X. So here we have two right triangles stacked on top of each other. And this is another place where we're going to have to use the Pythagorean Theorem twice. And so we'll find this hypotenuse, and then we'll use that to find this second hypotenuse. So let's go ahead and set up the Pythagorean Theorem. So for the smallest triangle, this smaller triangle here, we have one leg of 1 and one leg of 2. So let's go ahead and plug that into our Pythagorean Theorem. So here we have 1 squared plus 2 squared equals c squared. And our hypotenuse here, that's going to be c squared, and it is across from the right angle there. So let's go over to our calculator, and we have 1 squared plus 2 squared, and that's going to equal 5. So now we know that 5 equals c squared, and now we'll take the square root of 5. And so we'll take the square root there, and that's 2.236. But that's going to be the value here. We can actually leave that in the root form because we're actually going to use it again and square it. So it might be kind of easy just to leave it that way. So we'll just say c equals the square root of 5. Now we'll look at this larger triangle and solve for x, and that's going to be what we're looking for in the problem. So again, we'll set up the Pythagorean Theorem. We know this value here, this leg, and now we found this leg with our last problem, which is the square root of 5, and we're going to solve for the hypotenuse here, x. So let's go ahead and plug in square root of 5, that's one of the legs, plus 2 squared, and then we're going to find c squared. So whenever we square the square root of 5, we actually get 5, and then we square 2, and we're going to get, oh, that's the wrong thing. Let's see, 2x squared, that's actually going to be 4. And so 4 plus 5 equals 9. So now we know that 9 equals c squared. And of course, the square root of 9 is 3. So in this case, x equals 3. Now let's take a look at example problem 3. Here, we want to find the area of the shaded square. Now, this problem uses one of those special triangles. You can see one of the angles is 60, one is 90, and the other is going to be 30. And then we can actually solve for this leg, and then take the area of that square. Go ahead and try this, but we'll cover this problem in class as well.